Today we're talking about NASA regaining contact with Voyager 2 after it went dark for 2 weeks, and the ISS experiment to help scientists work out how to keep astronauts cool in space. Let's kick it off with NASA's contact with Voyager 2. NASA has reestablished connection with Voyager 2 after a tense 2 weeks of not hearing anything from the probe. On July 21st, the agency lost contact with Voyager 2 following a series of planned commands that mistakenly pointed it 2 degrees away from our planet. While it is scheduled to automatically reset its orientation on October 15th, it's not surprising that NASA scientists didn't just wait for that date to know whether the spacecraft is still running. Voyager 2 was launched way back in 1977, and it's one of the only 2 probes sending us back valuable data on interstellar space. For a few days after July 21st, NASA wasn't even sure what the spacecraft's condition was. It wasn't until August 1st that multiple ground antennas from the Deep Space Network, or the DSN, were able to detect a carrier signal from the probe. A carrier signal is what a spacecraft uses to beam data back to the ground, but NASA said the one DSN detected was too weak to be able to transmit any information. Still, it was enough to confirm that Voyager 2 was still working and that it hadn't deviated from its trajectory. Instead of simply waiting for October, Voyager's ground team decided to take action. They concocted a plan to shout a command to the spacecraft across over 12.3 billion miles of space using the DSN, telling it to turn its antenna back to Earth. The whole process illustrated just how vast outer space truly is. It took 18.5 hours for that message to reach the probe, and another 18.5 hours for NASA to start receiving science and telemetry data again, indicating that Voyager 2 had received the command. This isn't the first time NASA has had issues with the spacecraft. In 2020, it had to provide tech assistance from billions of miles away after it tripped a system that shut off its scientific gear to conserve electricity. Voyager 2 entered interstellar space. That means it exited the plasma bubble created by our sun back in 2018, becoming the second human-made object to do so after Voyager 1. Although NASA believes that both Voyager 1 and 2 could remain in contact with the DSN until 2036, it also says that science data won't likely be collected after 2025. The spacecraft could only be providing us information on interstellar space for less than 2 years, so it stands to reason that scientists don't want to waste a single day it can send data back to Earth. Now it's time to take a temperature check on the latest ISS experiment to help astronauts keep cool. On August 4th, Northrop Grumman's 19th resupply mission for the ISS arrived on the orbiting lab, carrying not just necessities for its inhabitants, but also an experiment that could greatly benefit future human colonies outside our planet. Specifically, the mission was carrying a module with hardware that could help us understand how heating and air conditioning systems can operate in reduced gravity and in the extreme temperatures observed on the Moon and Mars. Daytime temperatures near the lunar equator, for instance, reach 250 degrees Fahrenheit, which is higher than the boiling point of water. At night, temperatures reach minus 208 degrees Fahrenheit. The lowest recorded temperature on Earth was minus 128.6 degrees Fahrenheit back in 1983. The hardware was designed and built by scientists and engineers from Purdue University and NASA's Glenn Research Center in Cleveland. It will allow Purdue scientists to conduct the second part of their flow boiling and condensation experiment, or FBCE, which has been collecting data aboard the ISS since 2021. They've already finished gathering data for the first part of their study. That focuses on measuring the effects of reduced gravity on boiling. This part will now focus on investigating how condensation works in a reduced gravity environment. Issam Mudawar, the Purdue professor in charge of the experiment, explained, "We have developed over 100 years' worth of understanding of how heat and cooling systems work in Earth's gravity, but we haven't known how they work in weightlessness." His team has published over 60 research papers on reduced gravity and fluid flow from the data they've collected so far, and they're in the midst of preparing more. They believe that in addition to providing the information needed to enable human colonies to live on the moon and on the red planet, their experiment could also provide the scientific understanding to enable spacecraft to travel longer distances and refuel in orbit. Thanks for listening to the show. Make sure to rate, review, and subscribe on Apple Podcasts. Today's show featured journalism by Gadget contributor Mariella Moon and was produced by Spoken Layer. I'm Imran Sheikh, and we'll talk more tomorrow.
Spoken Layer.